Alright, welcome back. This is our second video on Chapter 6, Section 2, where we're talking about the inverses of functions. So, you might remember from last time, we talked about how to find the inverse of a function. It was a 4-step process. And so for example 3, which if you're looking at the note sheet, is the top example on the back of that sheet, we want to find the inverse of this function. F of x equals x minus 4. So we're going to go right through these 4 steps, and by the time we're done, we should have that function's inverse. So our first step here is to replace f of x with y. So we're just going to change this to a y. So we've got y equals x minus 4. Simple enough for that first step. Step 2 is to switch x and y. So I'm actually going to make this a little easier to follow, I'm going to put that first step right here. So y equals x minus 4. Step 2, we switch x and y. Remember, when we want to find the inverse of a function, we have to switch x and y. So the y becomes an x, the x becomes y. Everything else stays the same. So don't try and solve for one of these letters or do something weird like add 4 to both sides. Don't do any of that. Just change y to x and x to y. And you should be okay. Step 3, solve for y. We want this y by itself. All we need to do there to get the y by itself on this side is to move this negative 4 over. We add 4 to both sides. So we have y equals, these are going to cancel out, x plus 4. I know it's x plus 4 equals y, but I like my y being on the left side, so I just flip those sides there. Y equals x plus 4. And the last step is to replace y with f inverse of x. Okay, just to show that this is the inverse function. Okay. So, if our original function is x minus 4, we're saying that the inverse of that function is x plus 4. And maybe you could have guessed that from the very beginning. Instead of subtracting 4, you would add 4, and that's the inverse. It's not always going to be that simple. I would recommend showing every step of that 4-step process anytime you're asked to find the inverse of a function. And I'm looking at the homework assignment for this section, and it looks like you're going to be asked to do that once. Okay, so there will be a problem like this on that homework assignment. So if you can understand how we went through the 4 steps here, then that problem should not be all that terrible for you. Alright, so we've talked about how to find the inverse of a set of ordered pairs. We just flip the coordinates. We talked about how to find the inverse of a function like this. We go through our 4 steps. There's only one other type of problem in this section, and that type of problem is where you have 2 functions. So we've got f of x and g of x, and we want to determine whether they are inverse functions. And what that means is, it's asking whether if we take the inverse of this, do we get this? And if we take the inverse of this, do we get this? Okay, that's one way of doing it. What I'm actually going to have you guys do for this is something that you have seen in the last section with Miss Disher. And the answer here is going to be yes if we take f of g of x. I know it looks like f-o-g, like fog, but this is really telling you f of g of x has to be exactly the same as g of f of x. And they both have to be equal to just x. If we calculate both of these things and they are both equal to just x, then these 2 functions are inverses of each other. Now, if you've forgotten how these work, this composition of functions, that's perfectly fine. We're going to go through it here. Let's calculate this first. We want to find f of g So this is one way to write f of g of x. I prefer writing it a different way. I like writing it this way, and you'll see why in just a second. The reason I like writing it this way, I'm going to make this a little cleaner. It's an x in parentheses there. Okay. What this is telling us to find is we want to use the function f, which is this one. But instead of just plugging in an x here, see how we have g of x in here? What this is telling us to do is to use this function, but wherever there's an x, we're going to plug in the function g of x, which is all of this. So we're going to be plugging this entire function in for x here. That's right, cat. That's my cat. Okay, so we are going to have 3/4 times something, it's not just x, minus 6. And what we just said was, instead of just putting an x in here, we're plugging in g of x, which is all of this. 4/3 x plus 8. All of that goes in there. So we just need to calculate what this is all equal to. That shouldn't hopefully be too terrible, as long as we can multiply these things together, because we're going to want to distribute this 3/4 now, right? 3/4 times 4/3. You can multiply these straight across if you're distributing here. This is going to be 12/12, which is just 1. 1 times x is just x. Okay? Kat, do you have anything to add? Okay. Now we need 3/4 times positive 8. I know that's going to be positive, so I can put the plus sign there. There are two different ways to do this. Well, there are several. What I like doing 3 times 8, which is 24, divided by 4. 24 divided by 4 is 6. Okay. And if you need a calculator, if you need to plug that in to get 6, that's perfectly fine. But what we're saying is when we distribute 3/4 times these things, we get x plus 6. And then this minus 6 is still here. So, is there any way we can simplify what we have here? Yes, of course. We've got positive 6 and then minus 6. 6 minus 6? Those are essentially, they're 0. They're going to cancel out. So all this is equal to is just x. Hey, that's what we wanted, right? F of g of x has to be equal to x for these to be inverses. But we're not quite done because both of these things have to equal x. So as happy as it makes us that we've got this being x, what we need, this also needs to be equal to x. So we need to calculate g of f of x just like we calculated f of g of x. So let's do that. Okay. So let's draw on what we've done before to try and see if we can do this a little more easily. We want to write this a different way. Something more like this. But since this was f of g, it went fg. This is now g of f. So these two letters are going to be reversed. The g is going to be first, and this will be f of x in here. Okay. So, for this problem, the f was on the outside, so we used the f of x function. This time the g is on the outside, so we're going to be using the g of x function this time. So I'm actually going to write out this, but instead of x, I'm just going to put big parentheses. So we're going to have 4/3 times whatever we're plugging in. It's going to be this. It's going to be this. Okay? 4/3 times something plus 8. Okay? And what we're putting in these parentheses is f of x, which is this. 3/4 x minus 6. And so what we're going to have here is something similar to what we did here. We are going to distribute this 4 over 3 times both of these things. Okay? If at any time you feel like I'm going too fast through this stuff, you can pause the video, you can rewind, whatever it is you need to do in order to follow. Okay, that's actually an advantage over doing this in real classroom time. Okay, so 4 over 3 times 3 over 4, we already did that. They were in the other order here, but if we're just multiplying, this should be the same. So this is going to end up being 12 over 12, or 1, times x, which is just x. 4 over 3 times negative 6. Okay, that's a little different than what we did here, so we should multiply that out. I can put that negative sign here. And what I said was one way to do this is 4 times 6, 24. 24 divided by 3. 24 divided by 3 is 8. So we have x minus 8 when we distribute this. And then this plus 8 is here as well. And what can we do from here? Yeah, that negative 8 and the positive 8, they're going to cancel each other out. This is just x as well. Ha-ha! So we calculated f of g of x to be equal to just x, and g of f of x we found to be exactly just x. That is exactly what we needed in order to answer yes. So the answer is yes. These functions are inverses. Woo! At least we did all that work to say yes. It would have been disappointing if it were no, after all that. Okay? So, I wouldn't imagine that you would have a problem much more difficult than this, unlike a problem set or a quiz or a test or something, because it had fractions in there. It was actually really nasty. Okay? What you can expect is something more like the multiple choice problem at the end of the notes. You do need to determine whether these two functions are inverses of each other. So the process is going to look similar to this. You need f of g of x and g of f of x to be equal to just x. Okay? I lied, there is a fraction still in here, but it's just 1. F of x doesn't have any fractions in it, so it should be a little easier. Okay? So, let's go through. If you feel like you can do this problem based on what you've seen here, I wholeheartedly encourage you, pause the video, give it a try. Okay? Don't wait for me. But if you do need to see another example of how this works, let's go ahead and start by calculating f of g of x. Kat, you don't understand inverses? Trying to teach you? I'm sorry. She's got so much to say. We calculate f of g of x here. I like this one to be a little bigger. Okay, so let's calculate this. We're going to write down the f of x function, which is this. So 13 times something minus 13. But what we're plugging in is g of x, this function right here. 1 over 13 times x minus 1. So let's calculate what this is equal to. We got 13 times 1 over 13. So that's 13 times 1, which is just 13, divided by 13. That's 1. So this is x. Okay. Now we multiply 13 times negative 1. 13 times negative 1 is negative 13. And we've got this minus 13 showing out here. Okay. So we've got x minus 13 minus another 13. Okay. Okay. So what is this equal to? That's right. x minus 26. X minus 26. Is this equal to x? Is this the same thing as just x? No. If one of these 13s were positive, it could have canceled out and made x. Once we get something that's not just x, these functions are not inverses anymore. Because f of g of x has to be equal to just x for them to be inverses. So if you get something that's not x, you can stop. You don't even have to calculate g of f of x. How about that? Cut that problem in half. So the answer is no. And in the notes, the multiple choice, you know it has to be either A or B, because those are the ones that say they're not inverses. Why are they not inverses? Well, because f of g of x equals x minus 26. So the answer there is A. The answer is A. Okay? And there is going to be a problem like that on the problem set that you'll be working on for your next e-learning day. But I promise you, it is simpler than either of these two in terms of what the functions look like. They are easier to manipulate. They're easier to calculate f of g of x or g of f of x. So you should be okay with that. Okay? So that's it for the notes. You will have a problem set for your next e-learning day to work on. It will be due the next Tuesday. Okay? I'll make sure that I give you an email. You'll get all the information you need. But it won't be due until the next Tuesday. So, my cat and I would like to say that if you have any questions as you work through the problem set, you can email me and I will make sure that I help you as best I can. If you would like some one-on-one coaching in real time, we can use Zoom or Skype or any other video conferencing tool like that, so you can get some help on the homework. And you are the first class to get to see my cat in person. So there's my cat. She's crazy. Her name is Bella. Okay, so I hope you enjoyed this video. I hope it was helpful for you. I hope you learned something about inverses. Go ahead and give those problems a try. There are only a few problems on the problem set. I'm not going to kill you with a whole bunch of problems. Okay? So until then, I'll see you next time.